In the previous class, we were just doing writing formulas, na? Yeah. And we have cleared with that one. Then we started, that was a backup class. And okay, we are doing acid, bases, and salts. So let's start doing that one. Hey, wow. Aisha, you got 9.5 out of 10 in chemistry. Very good. Proud of you, beta. So in the previous class, we learned how to write the chemical formula of the compound. The next was Aisha and Kulsum. Okay. Now today, what we are going to study, let me explain this. Today's topic would be we have done the I think we have done the acid base indicator. Do we have done acid base indicators? No, we have not done. We were just on the how to write the chemical formulas of the compound. Okay. So today we shall be learning a special topic, and that would be the chemical properties of metals. Okay, we will discuss that one, but first we shall start the chemical properties of acids. Chemical properties of acids. Okay, these are very important, and let's study them properly. Chemical properties of acids. What are acids? You know that those substances that dissociate their H plus ions in aqueous are called acids. Okay. And those substances that dissociate OH negative ion in aqueous are called bases. And acid always shows their property in acidic or basic medium. Now, what's the first property that we're going to study here in acid, about the acid is that acids, when react with metals, it will give you salt plus hydrogen gas. Salt plus hydrogen gas. Got it? Like for example, H2SO4, don't write. You have to write when I ask you to write it. Okay. First you understood here. If you have H2SO4 and you are reacting it with zinc, okay. So the compound is going to form with, you have to remove the hydrogen from acids and try to make the formula using the zinc and sulfate ion. And in the previous class, I taught you that how you can write the formula of the compound. Like for example, you have zinc, so you have to write the positively charged element first. That has 2 plus 2 valency, and sulfate ion has also plus 2 valency. When there is same, they will cancel out each other, and you will have the formula ZnSO4 plus hydrogen gas. You understood? Yes or no? Understood? Yes or no?
Yes, sir.
Yes. Then we have after acids we have zinc, like we are having zinc sulfate, Zn H2SO4. When react with zinc, it will give ZnSO4 plus hydrogen gas. That you have H2 HCl. When react with magnesium, what it is going to give you? Tell me the name of the salt.
MgCl
MgCl, no?
plus
Check the formula.
MgCl2
MgCl2. Because magnesium has
plus
valency 2 and chloride ion has valency 1. You cross multiply these two, you'll get MgCl2 plus hydrogen gas. Got it? Got it? You are not allowed to write here right now. You need to understood only. Okay. Similarly, if you have HNO3 and you are reacting it with magnesium, that you have HNO3 and you are reacting it with magnesium, what you will get? What you will get? Tell me. Remove the hydrogen from the acids. You have magnesium and you have nitrate ion, NO3 ion. So magnesium has valency 2, nitrate ion has valency 1. What should be the formula?
MgNO3 whole
Mg
2.
MgNO
2, 3, and then 2.
Good choice.
MgNO.
Plus hydrogen gas. Very good. So if I ask you one thing here is that if you are having HNO3 and you are reacting it with magnesium, it will give you this one. Okay. Now there is a type of reaction that we studied in the first chapter, that is displacement reaction. So what is displacement reaction? Let me explain you first. Displacement reaction. When we have a group of elements and the reaction is taking place. So when we have displacement reaction, we are talking about displacement reaction, the reaction in which more reactive element displaces the less reactive element from the compound. More reactive element displaces the less reactive element from their compound. We called it displacement reaction. What we called it? Like for example, you have and how we will find that which element is more reactive, which is less. So we have a series, like we have potassium at the top, potassium. Okay, then we have sodium, Na sodium. Okay, then calcium, then magnesium, then aluminium, then zinc, and Fe is iron, then tin, Sn is tin, Tin, tin. Okay, and tin. After tin, we have the hydrogen. We have the hydrogen. Below here, we have hydrogen because there is no space. So start writing here. Hydrogen. Then we have copper. Cu is copper. And then we have, after copper, we have mercury. Hg is mercury. Then we have silver. Ag is silver. Then we have gold. And then we have platinum. Okay. So if I ask you that, so very simple. This is very simple, that which element is more reactive? So if I ask you, magnesium is more reactive than aluminum, or aluminum is more reactive than magnesium, which is more reactive?
Magnesium.
Yeah. The element which is present above at the
Magnesium.
top? Yeah. The element which is present at the top or above, they are considered to be as more reactive metals. Okay. So like you see that in the reaction that will, like for example, you have copper sulfate solution, CuSO4. Okay. For example, you have copper sulfate solution, you have zinc. So this is a displacement reaction. Simple. Zinc will displace the copper from its compound. It will get displaced and it will form zinc sulfate plus copper. Okay. Like for example, if you have uh, like you have ZNO when react with aluminium. So since aluminium is more reactive than zinc, it will displace it. It will form Al2O3 plus zinc. Okay, so this will be according to the reactions. But what if I have zinc sulfate ZnSO4 plus Cu? So here you see that zinc is more reactive than copper. So it will not displace. So there will be no reaction. No reaction. You understood? Means copper is less reactive than zinc. So it will not displace it. More reactive. In case it is displacing, zinc is more reactive than copper, it will displace. But here copper is not reactive than zinc. It is less reactive. So there will be no reaction. You understood now? Understood?
Yes.
Then up person, everyone, you understood?
Yes.
Now the same reaction is taking place with when acids react with metals. Metals, they are going to form salt plus hydrogen gas. This is also a displacement reaction. For example, you have zinc. Like for example, you have HCl and you are reacting it with magnesium. Okay. So according to the rule, magnesium is displacing the hydrogen. Okay, according to rule, magnesium is displacing the hydrogen. So we'll simply say that magnesium is more reactive than hydrogen. So it is displacing because you see here in the table that I have drawn here, magnesium comes here and hydrogen comes below 10. So magnesium is more reactive. So it will displace it. It will simply displace it and will form magnesium chloride, MgCl2. Why? You have to write the formula according to the valency chart. Your magnesium have 2 valency and chloride has 1. So that would be MgCl2. Don't write, if you write it like MgCl, it will be incorrect. And then you will have 2 hydrogen atoms, means they will combine together, they will form HCl. So this is more reactive. So in this case, the metal which are above hydrogen, they are more reactive than hydrogen. Simple. Those metals that are placed above hydrogen, they are more reactive than hydrogen. So they can easily react with the acid. But if I ask you that you have HCl and you start reacting it with copper, there will be no reaction. Why? Because copper is less reactive. Copper is less reactive than hydrogen, so it will not displace. Like for example, if you have Ag and you have H2SO4, there will be no reaction. Why? Because Ag is less reactive than hydrogen. Ag comes below hydrogen. It is not powerful than hydrogen. So it will not displace. Simple. Understood? So those metals that are above hydrogen in the reactivity series are able to react with acid to produce hydrogen gas, salt and hydrogen gas. You understood? Like the metals like copper, silver, mercury, gold, platinum, they are less reactive than hydrogen. They are less powerful than hydrogen. So they will not be able to displace. Understood? Yes or no? Zainab, you understood the concept? So now you start writing from the chemical properties of metals. Just sorry, acids is the first one. Start writing the reactions. Chemical properties of acids. Acids when react with metals will give salt plus hydrogen gas. Note it down and write all the reactions here that is mentioned with the with this is no reaction and the formulas, and then write that reactivity series also. Okay, write each and everything that is written on the screen. Done.
No,
You're still doing.
Still doing.
Okay, okay, do it, do it.
should we write the table also? Like the potassium, sodium, calcium, and all?
Yeah, this table is important. This table is important.
Done, sir.
Okay, Aisha. Junaid, Firdaus, and Noha, please turn on the camera. Done? Noted? Noah and
Um,
Kulsum.
I'm almost done.
Zainab,
Yes.
Noah, please turn on your camera. Why you joined late? Done? We are studying the metals, chemical properties of metals, and you have missed 15 minutes class.
Yes, sir.
Why you joined late, beta? Okay, so should I move forward? You done with this property? So if I ask you a simple question that how will you test this production of hydrogen gas? Means how means this hydrogen gas that is produced here. So how will you test that one? Is how can you determine whether this gas is hydrogen gas, carbon dioxide gas? The question comes in examination that how can you test the
If
hydrogen
there is
gas? This is a very simple
hydrogen
answer.
gas, there will be a pop sound.
Getting the pop sound.
Yeah, you're right. Noah, how are you? Are you there? Noah, are you
Yes,
there?
sir.
So please turn on the camera.
Sir, I can't switch on my camera.
Okay, beta. Okay. So what we are saying here is that that we are studying Noah the chemical properties of acids, and we have studied here that acids when react with metals, they produce salt plus hydrogen gas. And since the reaction between acid and base is a displacement reaction, so if the metal is more reactive than hydrogen, means in the reactivity series which are above the hydrogen, these metals only react with acids to produce hydrogen gas. Like copper, mercury, silver, they come below the hydrogen, they are less reactive than hydrogen, so they will not be able to displace the hydrogen on reaction with acids. So they don't react. Means actually the copper, silver, gold, mercury don't react with acids. Okay, to produce hydrogen gas. So here we have a question, right? Write down this statement. Those metals that come below hydrogen in the reactivity series don't react with water, acid and water to produce hydrogen gas. Actually, metals when react with acid, they also produce hydrogen gas. But in that case also, because acid is also containing what hydrogen and water also contain hydrogen. So we can simply write the definitions here that if you want to remove the hydrogen from a compound like HCl from H from HCl or H from H2SO4 or what H from water H2O. So the metal should be more reactive than hydrogen. Means it could be a zinc, it could be an aluminum, it could be a sodium, potassium, calcium, magnesium, but can't be metal like copper, gold, platinum. Okay, and then write this one that's the test for the hydrogen gas that hydrogen when passed through a soap solution, then the bubble filled with hydrogen is produced.
Then, sir.
Okay, you all done? Noah, you understood?
Yes, sir.
Okay. So what we are saying here for the next part here is that you Junaid and Kulsum, you done, beta? You done? Junaid and Kulsum, you done? Kulsum,
Um,
you stuck.
I'm done.
Kulsum got stuck. Okay. So there's a question comes in examination that what changes will you observe when you are reacting some metals, okay, during the productions of this, means there is a question. Let me explain you that that this is a diagram here, okay, and this is an NCERT question that you have a, like for example, like you have a test tube here, okay, test tube, and this test tube is going to have mm, and you are passing this solution to the hydrogen gas to produce for the production of hydrogen gas to the soap solution. But here you have acids in this one, a dilute H2SO4, a dilute H2SO4, sulfuric acid is there, and you are having zinc granules. Granules means bigger pieces of zinc. This is zinc granules, okay. So if I ask you that instead of zinc granules, if you took the zinc powder, then what would be the effect of the production of hydrogen gas? You don't need to answer this question. Answer me this question, Junaid. Junaid,
Yes.
if you take, instead of zinc granules, if you take zinc dust, then what would happen?
It is the same as
Hmm? Speak a little bit louder. What would
I
happen?
I don't know what would happen if we
Okay, just imagine, yeah, Aisha, can you answer this question? If you have instead of zinc granule, bigger balls of zinc, if you have zinc powder means very fine, delicate powder of zinc, you add the same amount of zinc powder, will you find any change in the production of hydrogen gas? Aisha, Zainab and Nova, will you find any change? Zainab, why are you not answering?
I don't
I
know.
think so.
I don't know the
Hydrogen gas.
Yeah, Aisha, I'm listening to you.
Hydrogen gas will produce fast.
Past, why?
Um, because it's powder, so it will dissolve easily in.
Yeah, you can say. Yeah, indirectly your answer is correct. What do you want to say? It is actually correct. What we are saying, just imagine you are having a chalk. You have seen a chalk we used to write in the school on the blackboard. Just imagine you dip the chalk, you take a glass of water, you dip the chalk and instantly get it back. What you will observe? The outer surface of the chalk will get wet due to water.
Yes.
Now break the chalk. Break the chalk. What you will observe? The chalk is dry from inside. You will observe this one. The chalk is
Yes.
dry from inside. Why? Because the inside particles are not in the contact with the acids. Sorry, water. That's why it remains only the surface. That surface that comes in the contact with the water, that surface get wet. Other the surface which is the particles which are present in the inner side of the chalk, they are not directly in the contact with the water surface, so they are dry. Same thing happens here in the zinc granules also. Zinc granules means they are bigger balls. And when you crush them, when you powder it, so what you are going, like for example, if you have a chalk powder, you crush that chalk, you have that powder on your on you take the powder and you make it on your hand, okay, like it is everywhere on your hand. You just dip the hand and come back, bring it back. So you will find that all the chalk get almost wet. Why? Because now you have increased the surface area. The particles which are inside the chalk are now are making a new surface, and we have increased the surface area, so they can easily come in the contact with the water and get dry and get wet. Same thing happens for the zinc granules. When you are having zinc granules and they are just converting into zinc powder, so the more surface area will increase. And when the surface area increases, then what is going to happen? When surface
The
area increases,
more
reaction
part
is
of granules are gonna
the
get.
reaction will be faster. Means before, if you think that the reaction was taking place to completely react with zinc granules, acid was taking 10 minutes. Now it may take 2 or 3 minutes. So reaction will be faster. Understood? Understood?
okay.
The second question comes in the same category. That what if instead of H2SO4 we take the HCl, hydrochloric acid, hydrochloric acid. So whether it is an hydrochloric acid or an H2SO4 sulfuric acid, both are strong acids. Both are strong acids. So they will react rapidly with that rate. So there will be no change. Almost the same rate of hydrogen gas will be produced. Okay, got it? And the question comes in
Yes, sir.
examination that instead of zinc granules, which we replace the zinc granules with the copper granules, then what would happen?
Same reaction.
It should be attached to same
Yeah,
same
Janet,
reaction.
you're saying something? Janet, you're still saying something?
It will still get attached to the hand like the zinc granules. Same reaction.
They will react.
The same
Not
way as the zinc
same way.
granules.
Same way. They
Yeah,
will react the same way. If you replace the zinc instead of zinc, if you take the copper.
it will react the same.
No.
Or
Actually,
No, I
copper.
think so. As copper is less reactive than zinc, then it will take some time.
Yeah, the copper come below the hydrogen in the reactivity series.
Yeah.
So there will be no
or
reaction. Nah? I've told you only those metals that are above hydrogen, they react with H2SO4. And if you have H2SO4 and you want to react it with copper, there will be no reaction. Because copper is very less reactive than copper is less reactive, so there will be no displacement. If it instead of zinc, the zinc is more reactive than hydrogen, so it will displace. But copper is less reactive, so it will not displace. Simple. You understood now the concept?
yeah,
And there is one more property that since we are studying the properties of bases only, but since we are having a question here, that there is one more property that base when react with metals, they also produce salt plus hydrogen gas. But here the name of the salt is little bit difficult. Like for example, you took NaOH and you reacted with zinc. It will give you Na2ZnO2. Na2ZnO2 plus hydrogen gas. This is the name of this reaction is sodium zinc. It will give you sodium zincate. We will learn this reaction again when we study the properties of bases or chemical properties of bases. This is called sodium zincate. So both acids as well as metals when react with means both acid and base when react with metal, they produce salt plus hydrogen gas. Understood what I said? That both acid
Yes, sir.
as well as
Yes, sir.
base, they are opposite. Acid and base are opposite to each other. But still, when they react with metal, they produce the same things. They produce salt plus hydrogen gas. But you have to write the name of 3 salts. Like this, the name of this salt is sodium zincate. Sodium zincate, that is very common. Yeah. And then we have sodium aluminate, and when NaOH react with aluminium, and we have sodium plumbate when NaOH react with Pb lead. So there are 3 salts that are important, and that is only that are going to come in your examination. Now coming back to the point, so start writing here that this question, that what changes will you observe when in place of zinc granules, some amount of small dust is taken. Write the question also and draw this diagram. Just draw the test tube and with hydrochloric acid, sorry, H2SO4 and zinc granules. It means just make the diagram only for the test tube. Just don't make this a stand, don't make this salt, don't make this make you are having an test tube in which is filled with H2SO4 and having zinc granules, and then start doing this question, please. Then instead of H2SO4, we take dilute hydrochloric acid. So we'll say that here the same amount of hydrogen gas will be produced. So write the answer properly in your copy, neat and
What's after produced at?
What are you saying?
Sir, in the underlined part, right? Produced
Produce at
at. What's
faster
after
rate.
that?
Produce at faster rate. Noah, are you writing? Are you writing? Noah, are you there?
No, sir.
Okay, okay. Are you getting this one? Ejina?
Yes, sir.
Okay, okay. Do this one.
Done.
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 Okay, okay. You done? So do this part also. You also done this one? Yeah, Junaid and Noah.
Yeah.
Yes.
You noted this one? Okay. So in place of zinc, if you take the copper, no reaction will take place as copper is less reactive than hydrogen. In place of dilute H2O4, if NaOH is taken, then the hydrogen gas will be produced in case of NaOH also, because when H2O4 react with zinc, it will give you zinc sulfate plus hydrogen gas. That was the previous reaction. But NaOH when react with zinc, it will give you sodium zincate. That is the reaction. Okay. So note it down up to here. This is very important question from the NCERT exam. You done? Noted? The next property, noted up to here, Aisha? Still writing.
Still,
Okay, write it, write it.
then
Okay.
Done.
So let's, okay, very good. So let's start the next part here. Okay, and the next property of acid is that acids when react with carbonate slash metal hydrogen carbonate. They are going to produce salt plus hydrogen gas. Sorry, salt plus water plus carbon dioxide. Salt plus water plus carbon dioxide. Water plus carbon dioxide. Okay. Like for example, let's first let me explain you that what is metal carbonate first. In chemistry, we have separate groups, like we have sulfate group. SO4 is sulfate group. Okay, and we have carbonate group is CO3 minus 2. We have phosphate group PO4 minus 3. Okay, we have nitrate group NO3. Okay, NO3 minus 1. So if these groups, if any one of these groups is attached with metal, so that is considered, like for example, if I'm having Na2SO4, according to the formula, you're going to have Na has valency 1 and sulfate ion is going to have valency 2. So you cross multiply this one, you will get Na2SO4. Okay, got it? Okay.
Sir, can you
So
explain again?
yeah, why not? So what I'm saying here is that Na2SO4 will be there because Na is going to have valency 1 and sulfate. So this is known as metal sulfate. So metals when attached with sulfate group, they are considered to be as metal sulfate. Metals when attached with nitrate group, they are considered to be as metal nitrate. Metals when attached with carbonate group, they are considered to be as metal carbonate. Okay, like for
Okay,
example, got it? Okay, like for example, we have calcium and we have carbonate group. Let's make their formula. So calcium has valency 2 and carbonate has valency 2. They will cancel each other. You will have CaCO3. So the name of this compound is calcium carbonate, but it is a metal carbonate. It is a metal carbonate. Okay. Like you have sodium carbonate. Sodium has valency 1 and carbonate has valency 2. So accordingly, the formula will be Na2CO3. Like CaCO3 is here. There is no 2, but here is 2. According to the formula, well, according to the valency chart, we have sodium carbonate, which is formula is Na2CO3. And we have calcium carbonate, which formula is CaCO3. So if you are having any metal carbonate, okay, and they are reacting with acids, okay, they are going to give you salt plus hydrogen gas. Similarly, like we have carbonate group, we also have the hydrogen carbonate group. And this is the hydrogen carbonate group, SCO3 with minus 1 valency. This is the hydrogen carbonate. When it react with metals, like we have CaHCO3, okay, they are reacting, they have valency 2, it has valency 1, Ca has valency 2, HCO3 has valency 1, and CO3, only CO3 has valency 2. So you will get here, they will get CaHCO3 whole twice. But here you will get 1 and here you will get 1. So it will be NaHCO3. So this is metal hydrogen carbonate. The name of this compound is sodium hydrogen carbonate. The name of this compound is calcium hydrogen carbonate, but they both are metal hydrogen carbonate because the metal is attached with the hydrogen carbonate group. And the previous one, here you can check, the metals is attached with carbonate group. So it is known as metal carbonate. It is known as metal carbonate. So whether it is a metal carbonate or it is a metal hydrogen carbonate, you see carbonate group is responsible for production of carbon dioxide. Okay? So it is a metal carbonate or metal hydrogen carbonate. If they are reacting with acids like Na2CO3, when you are reacting it with water, sorry, acid Na2CO3, when you are reacting it with HCl, like for example HCl. Okay, so if you are getting confused that which salt is going to form, you can predict easily that carbon dioxide and water will be formed because it is a metal carbonate, it is an acid. So metal carbonate when react with give you salt plus carbon dioxide plus water. So you can write the formula, but the name of the salt, how you predict this name of the salt? So that is very simple. Take the metal from any. Only you have to take the metal. Whether metal is reacting with acid, only metal is reacting with acid. Whether it is metal carbonate is reacting with acids, whether it is metal hydrogen carbonate reacting with acid, anyone, if you okay, whether it is a base NaOH, CaOH whole twice, magnesium hydroxide, any. If it is metal, if it is a compound is carrying metal, so take the metal of that one, only metal. Like you take this is metal carbonate, just take the metal only. Okay. And from acid, remove the hydrogen. Then which group is there? Only chloride. So they now make the formula. It's the priority that you need to make the formula of the compound according to that one. So NaCl will be there, NaCl salt will be formed. So what you are going to take, whether it is metal carbonate, when you are going to make the name of salt, or make the salt, that which salt is going to prepare here. So what you need to do is that you need to take the metal only, whether it is metal oxide, whether we have metal oxide reacting with acids, okay, reacting with acid, like for example, I'm just writing here, this is an acid, HCl or H2SO4, any H2SO4, okay, HNO3, and it is reacting either with right, MgO, let I'm taking metal oxide, reacting with carbonate like CaCO3, or it is reacting only with metal, like only metal, potash, sodium, okay, or it is reacting with a hydroxide, like we have magnesium hydroxide. So when you are making this compound with their respective, always take the metal. Only if it is only metal, then you have to take the metal. Whether it is metal hydroxide, whether it is calcium carbonate, only take the calcium. From magnesium, take only magnesium. Take the metal. So just and then write the formula accordingly. Okay, if you have metal carbonate reacting with acids, it will give you salt plus hydrogen gas. Now always from HCl you get chloride ion. If you remove the hydrogen, you will get only chloride ion. From H2SO4, you will get only sulfate ion if you remove the hydrogen. If from nitric acid, you will take nitrate and NO3. So make the formula accordingly. For example, if calcium carbonate react with HNO3, so what it will give you? Take the calcium only. Don't write the carbonate group. Whether it is metal oxide, whether it is metal carbonate, whether it is metal hydrogen carbonate, whether it is only metal, take only metal. That you need to take the calcium here and remove the hydrogen from acids. So if, like for example, HCl is there, so if you remove the H, you will get Cl ion. If it is H2SO4, you remove the H, you will get SO4. Okay, if you have SCl, HNO3, so accordingly which acid you are going to have, just remove its H and then make the
So
formula.
nitrate.
You will take NO3 and then make the formula according to the valency chart. If it is having 2, write down 2, write down here 1, and then make the formula Ca3, sorry, Ca
CaNO3 whole 2.
NO3 whole twice.
And
So we'll get CaNO3 whole twice, and then write the journal equation accordingly. You make the salt, then you know this is a metal carbonate, it is reacting with an acid, so it must give you salt plus carbon dioxide plus water. So do it accordingly. That's very simple. You understood now? Okay. Okay. So start writing those equations that metal carbonate when react with acids. Okay. They will give you salt plus hydrogen carbonate. Okay. One thing you need to note it down, that whether it is metal carbonate or metal hydrogen carbonate, the name of the salt will be same. Like for example, if you have NaHCO3, this is sodium hydrogen carbonate. When react with HCl, the name of the salt will be NaCl plus H2O plus CO2. Okay, or whether you are having Na2CO3, sodium carbonate, when it is reacting with HCl, it will give you same NaCl plus H2O plus CO2. There will be a difference of only balancing, but the same salt, same reaction will be there with the HNO3, magnesium hydrogen carbonate or magnesium carbonate only. But there might be a balance. This is already balanced. Sorry, this is already balanced. This you need to balance. There are two sodium. You have to write here 2 sodium. Okay, and there are 2 hydrogens. There is only 2. You have to write down here 2. There is 2 chloride and 2 hydrogen, and total the 3 oxygen, 1 carbon, 1 carbon. So this is now balanced. This reaction is now balanced. So there is a difference only of balancing, but the product will be same. Okay. So what you need to understand here is that you need to start writing first. Start writing. This one.
We already wrote this though.
What are you saying?
We just wrote this though, right?
Yeah, if you means I was just explaining you that time. If you have done this one, okay. Let's try doing the next one. Yes, I'm going to move the slide. Next slide. Just
Then, sir,
okay. So let's you note this one also. These reactions for the reactions. Please note down these reactions also, please. And write down this question also that what would happen when nitric acid is react with action. Actually, action is calcium carbonate. So write nitric acid when react with calcium carbonate will give calcium nitrate, carbon dioxide plus water. Note it down.